The Sahara Desert and the Amazon rainforest seem to inhabit the separate worlds, and this desert is actually a vast expanse of sand and scrub stretching across the northern part of Africa, while the Amazon rainforest is a dense green mass of humid jungle covering the northeast of South America. But you may be surprised to know that both these parts are actually connected to each other, and every year millions of tons of nutrient from Sahara Desert crosses the Atlantic Ocean and brings many vital elements to the depleted Amazon soil. Well, keep watching Gateway to Knowledge to know how this transatlantic journey takes place. For the first time, scientists have an accurate estimate of how much phosphorus makes this transatlantic journey. This phosphorus accounts for just 0.8% of the 27.7 million tons of Sahara Desert that settles in the Amazon every year. This finding can also help us to understand the role of dust in environment and its effect on local and global climate. We all know that dust is very important in many ways. It is an essential component of the Earth system, and it will also affect the climate, and at the same time it will also change the effect of dust. The researchers actually picked up the dust from an ancient lake bed, and it contains huge deposits of dead microorganisms that are loaded with phosphorus. On the other hand, Amazonian soils are short of phosphorus and other critical nutrients that get washed away by the basin's frequent and heavy rainfall. Thus, the entire Amazon ecosystem depends on the Sahara's dust to replenish these losses. This team of researchers actually focused on how Sahara Desert gets transported across the Atlantic Ocean to the South America because it is the largest transport of dust on the planet. The team estimated the phosphorus content of the Saharan desert by studying an ancient lake and from the ground station of Barbados and in Miami. Then they used this estimate to calculate how much phosphorus get deposited in the Amazon basin. And it took about 7 years to record this data. But it is too short to make any conclusion about the long-term trends. But we cannot neglect it because it is an important step towards understanding how dust and other wind-borne particles or aerosols behave as they move across the ocean. And we need a record of measurement to understand whether or not there is a fairly robust or fairly consistent pattern to this aerosol transport. Across the years, the pattern has been highly variable. There was an 86% change between the highest amount of dust transported in 2007 and the lowest in 2011. And this variation is due to the conditions in the Sahel, which is actually a long strip of semi-arid land on the southern border of the Sahara. Years of high rainfall in the Sahel were typically followed by low dust transport in the next year. Although the mechanism behind this correlation is unknown, this team have a few ideas. Increased rainfall could mean more vegetation and therefore less soil exposed to the wind erosion in the Sahel. And a second idea provides more better explanation to this, and it is that the amount of rainfall is related to the wind circulation patterns that sweep dust from both the Sahel and Sahara in the upper atmosphere, where it makes the long journey across the ocean. So we cannot neglect that we are not connected from each other because this is a very small world and we are somehow connected to each other. So continue your journey with us to know more about other interesting information and ideas.